So for today, we're going to be doing just something a little different. We're going to be making sure that things are decoupled so we can actually have, what do we call it? Modularity, so we aren't stuck. So last time you remembered, we had a shooter AI, and we had a few things inside it. So one of the things we had before was we had a pathmaker node, and we also had Navmesh check, and then pathmakers and Navmesh and all this stuff. Now, what we want is we want to move it to another, what do we call it? Navigation code. So what we did was we made another class called a navigation maker. It's the same style, a component base, but what it does is it takes the list of obstacles that we have and a list of path points. So let's say we had like, alright, and then let's just say we have something like this. So like one pathing is like this, so our regular path that we made, and another one could be like something from here. So like if you had like a bunch of little enemies or obstacles, whichever one, you would have like points here and here, or like here and here. You can put it in a specific structure, and what happens is we're gonna let this class do all the heavy lifting of, you know, creating the pathways, and then from there we're gonna just send that information out to like our pathmaker, and then pathmaker would just move from path to path, or because the way I'm thinking is the navigation maker will give you the points that it will take to get there. So if you had 1 point here and 1 point here, like in our case 1 and 2, it would make a point from here to here, and another point here to here, and then here to here, right? And stuff like that. So this is just going to be our path making ability. Maybe we could just do something like, now for now let's just keep it as a circle, and what we're gonna do is we're gonna remove that movement from our obstacle, because we're gonna make it like, if we say this was a whole room, right, we're gonna say that this would be like a table, or like a wall or a statue in the middle of the area, right? Unmovable. Now you can make it move, but then you also have to update path or navigation via runtime. That does take a bit more performance, so most games just put obstacles as like placeholders for more, what do we call it? Convenient pathway making. But anyways, with that, we're gonna make that navigation maker, and then we're gonna have the path maker, just one of them this time instead of two, and we're gonna have a navigation maker, what do we call, pointer, so that we can check into it. And just doing that, you can already see what I'm going to do with it. So navigation maker just has an init, we just get all the paths, and then we save it into our vector of a list. So every time we want to go back to like the original path that we created like from editor, we can always go up to it. And yeah, and if any other function or like any other pointer calls to it, and we want like all the paths, or we want a specific path, then we can take that. We can also do is, I'll add one more later, and it's create a path, or create a path route, and give it to whoever's calling it. So it will create like the points between 2 points, or like the path between 2 points. The next thing I did was the path maker removed its component, so now any object can hold it, and it can just use the list of the path points, which is going to be this guy. It's going to use that, and then it's going to move objects along that path. Alright, so why are we doing this? In Shooter AI, as you can see, we already have a few red lines, and that's nice, because now we can just delete all this. We can delete all this, right? And then We can also delete this stuff and this stuff and this stuff. So now our code is slowly starting to look cleaner and cleaner, right? So let's move this with the render. It's technically a render, so we're gonna move that render there. And yeah, so our code is slowly looking cleaner. And then let me just code the rest of the stuff. Alright, so after coding all of that, what I did was I added one more overload to our get path, and this time we have a vector of points. So let's say if you had like a bunch of points and you want the pathing behind it, and the points are like all over the place, but they're inside the mesh. So what we're gonna do, we're assuming it's inside the mesh. If you have a point outside, it's gonna give you an error, and for that there's extra logic, but let's just say they're all inside the mesh for now. Right? So these points, they're in the mesh, and I just wrote this. First, when we initiate, we get all the pathings, and then we just do this function, which basically gets the path points between the path route, and then after that pushes it into a vector3, which we push it inside into a list of a vector3 list of a vector3. Yeah, and then with all that, we also made an overload where if someone gives you his own points and you just want the pathing between those points, you get this. And oh, forgot about this part. New points. So now it returns all that correctly. Okay, so that's done with that. For PathMaker, what do? We technically didn't change anything, except when we make our constructor, we have a duration time and we have the path points. So as you can see, vector3 path points. So it will take a path point and we can put all these inside our shooter AI. So what it will do is it will take the positions in world and it will then create us a path with our little what do we call function. The thing is, we did change a few things right here. So over here, what we did was we took path points num2, or like the second path point, minus path point num1. Now, what is the difference between this? So if you do a vector subtraction, it basically, if you have two vectors pointing in different directions and you do a subtraction, it basically points the second vector to the first vector. So the arrows will point. So if you had an arrow facing, let's say, left and the other one's facing top, or like facing 9 o'clock and the other one's facing 12 o'clock, the resultant vector will actually be starting at 9 and facing 12. So kind of like a triangle. It will be the hypotenuse of those two angles. And so using the same logic, we just reverse the numbers over here, and that will give us the end tangent, right? So this one's the starting tangent, which is facing towards the direction that we want, which is the next number, and this one's the end tangent, which is facing away, which is perfect. So with that, we didn't really change anything else. We just kept it. The only thing we changed was, because we're not using component, we have to make sure it's inline or else it's going to give you an error. So the next thing we're going to do is actually we're going to call these inside our shooter AI, and then we're going to just do this logic a little bit cleaner, or maybe about the same. Right? And now, is there more things we can change? Definitely. We can definitely change this. We can definitely add it inside our path maker. I'll see if I should or not, but at the current moment, I'll keep it here for now. And honestly, I should just add it here. Alright, by adding that into our path maker, now we have our logic completely separate. So the navigation itself handles making the navigation between the whole Navmesh and giving you the points. The path maker gives us the pathing using the spline graph. Now, to be honest, we could use the path path route, and there's no problem with using it. The only reason I'm using a spline graph is because I already wrote it down, and I don't feel like doing 2 times the job that I did. But definitely you have both options. You can use the path routing, you can use the path route pointer, and when you create the 2D between it, like right here, if I just press comma, we also have a delay, so it takes a while before it creates it, and then we can do a whole type of calculation and then moving along the path within a set speed, right? But all that we've already created in our path maker, so we don't really need to do it. So now our logic is basically navigation maker makes our paths and gives it, or keeps it. In our case, it keeps the standard ones, or the ones that we initialized in our base, right? Then it also gives you a custom path if you decide to give it like a bunch of points and you want navigation between it. Next, path maker takes those and it creates a path between them, and it moves along that path. Alright, nothing too much. It also has its own orientation with move towards and rotate towards, right? Moving rotation, orientation, then moving the object itself, rendering the path, and we also have move along the path. Now the next thing we can do is we should also have one that says get current object. We could definitely do that because, or we can say, or we can make one more function and say it move towards the object, which would be move over here and the object, and then the thing is over here. So we can make a little function, call it move towards, or we could do, let's see, where's a point, which would be this one. So what we can do is we can send this up, and I guess I'll do that later. But yeah, so what we can do is we can say move towards, and then we have the specific point which we stopped right here. But anyways, we'll do that later. So now we have the logic decoupled over here. We can also do a bit more over here where we can do the rendering or the view, matrix, and logic. So the whole viewing of the AI, we can put that in another class, and I will do that. And then after that we can have very clean code, and then the AI class would only be worried about the state, which is exactly what we want. So for the shoot, I'm probably gonna have to make, you guessed it, another class. But this type of coding is called composition instead of inheritance, because we're not inheriting anything. What we're doing is we're taking different classes and we're going to be using them as a composition, or like as wheels and parts of a tire, or of a car. So like parts of a car fixed together, creating the whole car. In this case, parts of the machine AI logic in order to create an AI. And then we can go a bit further and we can use shooter AI as a, what do we call, as a pointer for a list, and then we can have like an AI manager. So we can have like multiple AIs, like one over here just doing a little patrolling here, another one here, third, fourth, or something like that, right? And you can move around and kill, and if you shoot, or if we do melee, which I might have to, you won't alert the others, but if you shoot, then you're gonna alert all of them and they're just gonna come towards you, right? Something like that. So that's the basics of what we're gonna do, doing a little bit more advanced AIing, and I will leave you on that. I am definitely gonna change or decouple a bit more, so we're gonna make like something like AI view, I guess, or like the viewing area, viewing logic. I'll give it a cool name. Then afterwards we're gonna have another one for this guy, which is basically our so what we can do is we can call all this in detect maker, right? detection maker. So one is detection via looking, and the other one's detection via body pointer, right? And with that, I will see you guys next time. All right, until then, goodbye.